So this is an experiment, and this is my design surface, and I like to refer to this guy as sort of a love child between OneNote and SQL Server integration services. If anybody's done any sort of work with Microsoft CTL tooling, and it's like OneNote because the experiment name is up here. So I'm going to call this guy guesstimate, which is a made-up word, as you can tell. And what I need first is to import my data. And there's a lot of options here. As I mentioned, you can reach out to Azure and pull in stuff from a Hadoop cluster, from a relational database, from a text file. But I'm going to keep things simple for the sake of brevity. And I'm going to bring in a sample data set like this. And this is the adult census from the US. It's not the whole thing, because it'd be 300 million records. But it is 32,000 rows in 15 columns. And we have stuff like people's age, working class, level of education, marital status, occupation, relationship, race, sex, how many hours per week they work, native country, and their income. Yes, please.
Does Azure provide sample data sets?
Yes, it does. There's, I think, 24 of them. But if you want to pull in, what was that? Yeah, different types. So there's stuff that you can leverage to if you're working in fintech, for example. There's loan applications. There's all sorts of stuff in here. Let's see. Airport codes, bike rental. A picture of Bill Gates in RGB. Blood donation data, breast cancer. CRM churn labels. There's all sorts of movie ratings from IMDb, movie tweets. There's all sorts of samples data set that will allow you to quickly get started. And if this is not enough for you, you can reach out to Kaggle, for example, which has a bunch of data sets that you can leverage. I once did this presentation where I went out to Kaggle and I took their Titanic survivors list as a CSV file, and the prediction was, will this person survive or not? Well, if they're on the Titanic. But I felt that was too morbid, and I switched back to guessing people's incomes, which I think is appropriate given the time of the year. I think most of us have performance evaluations. Okay. People are honest. I appreciate it. Okay.
You can do a guesstimate on that.
So one of the things we would want to do, obviously, as we're evaluating the data set, is try to summarize it. And let's see, it's going to be hard doing this with one hand. Okay. So we already have an experiment here that has two components, and at this point I need to run it. And what this will do is it'll take my 33,000 rows and feed it into my data summarization component. And what this guy does is it produces a nice visualization which sort of does aggregates across each column in my data set. So it looks at age, right, number of unique values, missing values, minimum and maximum. Oops. Multi-touch, sorry about that. In one of the so one of the interesting ones, for example, is hours worked per week. Right? Somebody said that they work 99 hours a week. I think that's a bit much, right? So if we were doing this for real, we would want to cap that at a reasonable level. 80 is, I think, acceptable, right? Yes.
Do they provide an API for all the operations?
If they provide an API. Yeah, certain stuff you can do through an API. I don't think you can sort of build all your own UI on top of this guy. But what you can do programmatically, for example, is update a model. Right? So if you need to update it based on a new data set pretty frequently, that you don't have to do that manually. That was a feature that we added in April, which allows you to essentially retrain your model every once in a while. Okay, and one of the things I forgot to point out is, for example, one of the columns has blank data in it, and that is, universe doesn't want me to have a good demo.
Or just wants to make all those structures.
Apparently. Okay, so we're going to switch gears and we're going to cheat. We're going to jump to the final result. There we go. And because doing this in step by step would be better, but unfortunately we're not going to have enough time to do that. So what I was going to show you is that the country of origin column has a bunch of blank fields. And that is very counterproductive for data machine learning. So the toolset has a nice, clean, decent data column, which allows you to swap out nulls and blanks with explicit values. In this case, my replacement value is going to be unknown. We could have gone with like Narnia or some fun country name that opted to be more traditional. Then we're going to do a simple column projection. Right, so I started with 15 columns, but I don't need all of them in order to do my prediction. So what I think is going to be relevant to me guessing people's income is people's age, working class, education, battle size, occupation, race, gender. Unfortunately, gender does have a bearing. You know, hopefully that'll change by the time my daughter grows up. But for the time being, it is what it is. Right, number of hours per week, native country, and obviously income. So I dropped from 15 to roughly, I think, 10 or 12 columns. The next thing I do is I split my data into two buckets. One bucket is going to get 80%, the other bucket is going to get 20%. And what I do down here is actually train a model. Right? I feed in an algorithm, which in my case is called a two-class averaged perceptron. That sounds simple, right? It sort of sounds like the name of a Transformers robot, but it is actually one of the oldest algorithms in the machine learning space. I think it was embedded in the 60s or something, so it's been around for a while. It's an oldie but goldie, if you will, sort of like the hop-on of machine learning algorithms. Yes, please.
Why do we need to split the data into two segments?
I'm going to get to that. I think you already got it. You see, I'm learning. It's human learning. And we split the data because I have a trained model, and now I want to see if it's any good or not, right? I've got 32,000 rows. I'm going to train my model with 26,000. And the rest of them I'm going to use to evaluate the accuracy of my model, right? I'm going to apply it against my evaluation data set, if you will. And then I'm going to see how well it did down here in this evaluate model component. And I have the same thing over here on the right, except I'm using a two-class neural network, right? So average perceptron on the left, neural network on the right, train two models with the same data set, evaluate them with the same 20% of my data, score them, and then compare the results. And this guy I already ran, so let's see the results with this one, for example, right? So what we have here are my original sort of 10 columns plus 2. You see 6,500 rows were the, my test data set that I wanted to guess income for. This is the correct value that came in from the census. And this is the value that my model guessed as being that individual's income. And if we scroll down, it's looking pretty good. Pretty good. There's an error here. So it's screwed up with this one. And the good news is we don't have to scroll in by hand and count which ones it did right and which ones it did wrong. There's the evaluate model component, which very nicely shows me a comparison, right? So the blue chart is the model on the left, right, I guess, and the red one is the model on the right-hand side. And we see that the average perceptron actually beat out the neural network, which is good. But it's not a very big difference, right? So the most important sort of performance metric that we look at is the area under the curve. Right? It's this guy up here, right? So if you were flipping a coin, we would expect to get a 50-50 accuracy level, right? So 50% area under the curve would be 0.5. So then that line would be very, very close to the main diagonal. So 0.881 means that we have 88% chances of guessing somebody's income correctly based on these 10 attributes, which is pretty good. You don't have to take my word for it. Yes?
You want to mess around with this tool. How much do we need?
I'm going to get to that. It is, what I can tell you is it is inexpensive.
What is the work server in the neural networks?
That is a good question for a data scientist. I am not a data scientist. So it's called experimentation for a reason. Obviously, these are the defaults. All of these algorithms have a lot of advanced properties here. A lot of them. I'm not going to pretend that I understand what the heck these things do. Because remember, I wasn't a great student during college. This one has fewer parameters. But the good news is there's documentation. No, not this one. Where is it? There's a help section in here somewhere. Oh, here it is. More help. That details out what each of these things influences. Yes, please. Yeah. Yeah, it is. It is. You can compare and contrast, right? You can only do two at a time, but it's essentially sort of a last man standing kind of thing. So you have about half dozen, binary classifiers, and you figure out which one is better suited for your data set. Right? And you compare these two. This one's better. Then for this one, oh, this one won. Take that one. It helps, right? It helps in terms of, maybe you don't want to spend several days experimenting. And if you want to be really ambitious about it and reach that 90% level, you're going to want to tweak these defaults here. Yes, please.
If you said about the income, where do you set it?
Where do you set the fact that we want to guess the income? It is on the train model piece. And I told it that I wanted to guess the income. It would have been better if I'd been able to do this, one component at a time, but I had to skip over ahead because of the internet issues and because I can't play very well with just one hand.
How is the 50K which you chose? I guess it impacted a lot the results. How did you choose the 50K?
That is just how the data set came through. And looks like I had a box of candy left in here. Most recently I asked, so you get it. That's just how the data set came through, right? If you imagine you're going to somebody and so how much do you make? Exactly. People are more comfortable just talking in ranges, and that's why this data set is like that. But you can just as easily do guessing somebody's favorite color. So instead of doing a binary classifier, which means you're splitting people into two sets, you do a multi-class classifier. And there are algorithms in the tool set that allow you to do just that. So if you look at the toolbox, somewhere down here, there we go. Classifications, multi-class, decision forest, decision jungle, right? So, and there's a bunch of two-class ones, right? So if we wanted to find the absolute best one to identify people's incomes, we would have to work our way through these guys and then tweak those parameters until we got about 88%, which is what our best one is doing right now. Okay. So 88% is pretty good. We're going to pick the left-hand side one and select it. And what I'm going to do now, I guess I have to run it again. And this is being run on Microsoft's infrastructure here. They have a set of dedicated machines that execute everybody's models. And you'll see while a component is waiting to be executed, it has this sort of clock face. While it is running, it's going to change into a spinning circle. And I can't zoom out anymore. And once it's done, it gets this green checkbox up here. And what I would want to do now is click on the successfully trained model, and I want to create a predictive web service, because I mentioned that a model taken in isolation doesn't produce a lot of business value. We want to expose this guy as an API. So you guys want to, you're going to want to pay attention to this one because it's pretty fun. So clicked, produce API, and whoa, it was magic. So what this guy did is it sort of serialized the state of that air conditioning. Come on. It serialized the state of that training model into this component here. It added a web service input. We can just zoom in, which I can't do. So it added a web service input and a web service output. And if I wasn't running out of time, I could show you guys that right now I have a HTTP endpoint, which exposes a REST API that allows me to make batch queries or point-in-time requests to my model. I get an nice user interface that allows me to specify those 10 attributes, and I get back as a result set, that income.